All right, class, welcome back. This is Algebra 2, Lesson 5.6, and it's graphing quadratic inequalities. So Algebra 2, Lesson 5.6, graphing quadratic inequalities. All right, this is actually the start of our Chapter 5b, so second half of Chapter 5. And if you look over here on the right, you can see that we've got the graphing form for for a quadratic inequality. So it looks just like an equation. The only difference is you've got the inequality symbols there in between. And again, I'm showing you all the possibilities of what we could have when graphing or when having an inequality. All right, so let's get going here. Number one, when graphing inequalities, a greater than or equal to or a less than or equal to means the points of the function are part of the solution. That's really important. It means every point along the line makes the inequality true because it's the equal to part. And remember, the points on the line are the equal to part. So therefore, when graphing a greater than or equal to or a less than or equal to, what kind of line do you use? Do you remember? All right, it's a solid line. Solid line. And again, why? Because the points of the function are part of the solution. It's the equal to part. All right, second statement, when graphing inequalities that are greater than or less than, the points of the function are not part of the solution. Therefore, what do you use? And hopefully you remember, use a dotted line. Okay, why dotted? The points are not part of the solution. The points of the line are the equal to part. Things that are greater than are not equal to. Things that are less than are not equal to. And therefore we use a dotted line. Okay, so let's take a look at number 2 here. What's the other aspect that we have to remember about graphing? When y is isolated, right? When y is isolated, on the left, a greater than or equal to, or just a greater than, implies that you must do what above the function? And hopefully you remember we have to shade. Remember, inequalities must be shaded. The solution set is shaded. And the solution is the points on the line, if it's a solid line, and all the shaded points. So it implies you must shade above the function to indicate all the points of the solution. All the points of the solution. So you can see here I've got an example. I've got y greater than or equal to 1/2 x squared. And so a greater than or equal to tells us to shade above the line. Where are the points that are above the line? And it would be these points up here. So really, in this case, points inside. Now, if you get nervous and you're not sure, you can always do a test point. Take any point in that area, and I'll use a simplistic one. I'm going to go right there. And that point has coordinates of 0, 3. Put the points into the original function and see if you get a true statement. So if I put the 3 in for the y, I get 3 greater than or equal to 1/2 times 0 is 0. Is that true? Yes, it is a true statement. We found the correct points. But again, if you understand what the symbol means, you've got the variable isolated on the left, then you know to shade either above or, in our second instance here, below. So next statement, for a less than or equal to or greater than or equal to, you must shade below the function. Shade below the function. So here in our next example, we've got a less than. Our y is isolated on the left-hand side. That's important. And so the function is graphed. Notice it's a dotted line. And why dotted? Because again, understand that each of these points along this line do not make the inequality true. They're the equal to part. None of those points make the inequality true, and therefore they are not part of the solution. So we use a dotted line. Less than, we're going to shade below the curve, below the function. And again, if you're nervous about that, you can choose a test point and see if it makes it true here. I'll show you a false test point. What if I took this point right here? This is the point -1, 0. Now this should be false. Let's stick it into the inequality. 0 less than or equal to 1/2. We've got -1 for x plus 1. All right, -1, -2 is a -3. -3 squared is 9. 9 times -1/2 is -4.5 plus 1 is a -3.5. Is 0 less than a -3.5? No. Again, would I normally do all this? Not at all. There's no need to. If I understand the symbol and understand what it represents, I've got my variable isolated. And remember, it's got to be isolated on the left-hand side. Then less than or equal to is the shade below the curve. That's all I need to do. That's going to take care of things. I'll be in great shape. Okay? Let's go on. All right, so I've got an example for you here. How would you shade the graph of y less than or equal to the quantity x plus 2 quantity squared plus 1? And there's the correct graphing of that function. We used a solid line because it's a less than or equal to. All right, where would you shade? Where would you shade this function? Pause if you need to. I'm going to show you the solution right now. And so you would be shading below, right? So when you start below, what does that include? Well, that includes all these points out here and also all these points out here and everything below. Now remember, the curve is heading up. Now it is heading out slightly as it heads up. It is heading out slightly as it heads up. So it'll keep going out right, out left, and you'll keep continuing to have those points that are part of the solution. Quite a bit of points are the solution, but that is the way it is. Okay, let's go ahead and do this last example. All right, so what would you do if you were asked to graph y greater than 1/2 times the quantity x plus 2 quantity squared minus 1? What would you do? Well, again, you're always thinking, hey, this is quadratic. You'll say it's already in graphing form. I'm happy about that. So we want to state, is this a max or a min? Which one is it? Hopefully you're thinking it's a min. What are the min point coordinates? All right, you should be thinking -2, -1. What's the line of symmetry? And hopefully you're thinking x equals -2. Okay, so we're going to plot the vertex at -2, -1. And we are right there. And I'm going to show my line of symmetry. All right, we're ready for an XY chart. Okay, so again, don't forget where you're at. Where am I at? I am right there. What are the coordinates of that point? The x coordinates are -2. So it's logical. I could use -1 if I want as the next point, or remember I told you with fractions, if you go by 2's. So I'm going to go 0. I'm going to go 2 to the right of -2. All right, put 0 back in for the original. And so that would be a 0 there, right? 0 plus 2 is 2. 2 squared is 4. 4 times 1/2 is 2. And 2 minus 1 is 1. And so we have the 0.01. Come to my graph. 0.01. Hey, from 2 to the right, I know I'm 2 to the left. And we've got our second point right there. And again, I'm going to go 2 away here. So I'm going to go to 2. Put in 2 for the x. 4 squared is 16. 16 times 1/2 is 8. 8 minus 1 is 7. And we've got the 0.27. All right, so 2, 1, 2, 3, 4, 5, 6, 7 right there. If I am 4 that way, 1, 2, 3, I am 4 this way. All right, pause it if you want to and finish it. If not, I'm going to show you what I'm going to do here in a second. Okay, so I look at my symbol. It is not an equal to, therefore I have to use a dotted line, right? So I'm going to connect these points with a smooth curve using a dotted line. And next I have to determine my shading. Greater than says shade above the line, and therefore then I'm shading in here. Okay? That's what we're doing. We're graphing quadratics. Not very hard. All right, turn the back of your sheet here. Let's do number 4. All right, so I asked you to state if it's a max or min, the vertex coordinates, the line of symmetry, and then graph. And of course, we're plotting the vertex first, right? And then the line of symmetry. Okay, so pause it if you want to do it on your own. Max or min, negative there. So you're going to say, hey, that's a max. Max point coordinates, all right. 2, and what did you get? I hope you got 0, right? 2, 0. Remember your format. A times the quantity, x minus h quantity squared, plus k, right? And your vertex coordinates have values of hk. Well, the h is clearly a 2. And what's the k? Hey, it's not there. It's plus 0, right? That's the situation. So we've got a max at 2, 0. So a max at 2, 0. I want to plot that point. And so we are right there with a max at 2, 0. Line of symmetry. X equals 2. This is a max, so we know we're opening down. And we're right there. Okay, I'm ready to roll. Next point. Again, I'm going to look at the situation. I'm already at 2, right? So therefore, I'm going to start at 3. Go back to the original. 3 minus 2 is 1. 1 squared is 1. 1 times a negative is a negative 1. 3, negative 1, right there. Line of symmetry, same distance to the left of the line of symmetry. Okay. I'm going to go to 4. Put in 4 for the x. 4 minus 2 is 2. 2 squared is 4. 4 times a negative 1 is a negative 4. And we've got the point 4, negative 4. 1, 2, 3, 4. I'm 2 to the right of the line of symmetry. I'm going to go 2 left. You know what? I'm going to do one more point. I am going to use 5. So I'm going to go one more point here, going 5. Okay, so stick in 5. 5 minus 2 is 3. 3 squared is 9. 9 times a negative 1 is a negative 9. We've got the point 5, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I am 3 to the right. I'm going to go 3 to the left. Okay. Are the points of the parabola included in the solution? Yes, because it's an equal to. Therefore, I use a solid line. Every one of these points will make the inequality true because they're the equal to part. And now I have to look and say, where do I shade? Where do I shade? And this is a greater than or equal to. And therefore, I have to shade above. And what does above include? All of this out here. And there's our solution. Not hard. Not hard. We know how to do this. You just got to put a few things together. Let's do another one. Okay, so you look at this and you say to yourself, this is how you approach a problem like this. All right, they tell me to graph this. And you say to yourself, I need to know whether it's a max or min, and I need the coordinates, and I need the line of symmetry or the axis of symmetry, right? And so you look at this and say, oh, I don't know any of that stuff. But then you say to yourself, oh, wait a minute. What was that method we learned? And hopefully you remember the method of completing the square. That's what we've got to do. We've got to complete the square so we can put this thing into proper form. Okay, if you want to do it on your own, pause the video. If you want to watch, I'll review how we complete the square. All right, so if you remember, we're going to group our variable terms. Y greater than the quantity negative 2x squared plus 20x, leaving room minus 47. And look, I've got to factor out that negative 2, right? Remember that x squared term's got to be with a 1 coefficient. I've got to factor out that negative 2. So if I take that negative 2 out, that becomes 1, and this becomes a negative 10, right? It's just as if I divide it by negative 2. A negative 2 times a negative 10 is indeed a positive 20, and then times the x is x. Okay, so that's what I needed to do. All right, do you remember how to get what goes inside? I hope you do. I hope you say, oh yeah, I'm supposed to take the b value, which is now what? It's a negative 10. I'm supposed to divide it by 2, and I'm supposed to square it. So 5 squared is 25, and so a 25 goes inside the parentheses. And do you remember what to put on the outside? All right, be careful now. This is that special situation. Because remember, this is a multiplier distributive property, and in reality, we actually put in a negative 50. So to keep it equal, we've got to add its opposite, a positive 50 on the outside. By putting positive 25 in, we really put in a negative 50, and we got to add positive 50 outside. Okay, finish completing the square. Y greater than negative 2 times the quantity. Remember, square root of the first goes first. Sine of the middle is in the middle. Square root of the last is last. It's quantity squared. And then we get plus 3. Okay, now can we answer our questions? Yup. There's a max at 5, 3. It's a max at 5, 3, and we've got a line of symmetry of x equal 5. All right, I'm ready to roll. So there's my vertex, right? A maximum. All right, so I just graphed the point 5, 3. I'm going to show my line of symmetry. Ready to roll, right? What's next? Hopefully you're thinking xy chart. Okay. Now again, remember where you're at. I'm out here at 5. That's where I'm at already. What's the next? What do I want to use for an x? I want to use 6. Don't use 0. You're going to be all goofed up. Going 1 point over. I'm going to use 6. Okay. Put in 6 where the x is, right? Look right here. That's what I'm doing right now, right? I just put a 6 in for the x. 6 minus 5 is 1. 1 squared is 1. 1 times a negative 2, right, is a negative 2. Negative 2 plus 3 is a 1. I get the 0.61. Graph it right there. Line of symmetry right there, right? Looking good. Let's do the next point. I'm going to go 7. Put a 7 where the variable is 7 minus 5 is 2. 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 and 3 is a negative 5. That's 0.7, negative 5. 1, 2, 3, 4, 5. I'm 2 to the right of the line of symmetry. I'm going to go 2 to the left. That's enough. Dotted line or solid line? Look back at the original inequality. It's a greater than, not a greater than or equal to. The points of the line are the equal to part. They are not included, and we know that by a dotted line. Okay, where are you going to shade? Where are you going to shade this one? And hopefully you are shading outside, right, for a greater than. Right, all the points above for this greater than. Okay. Hey, if it would have been a less than, look back at the original. What if this would have been a less than? It would look exactly the same, and we would be shading in here, right? If it would have been a less than. Wasn't? It was a greater than, and therefore we shaded above the line, which then was everything outside. Not hard. Not hard. All right, let's do the last one. So this is an interesting situation here. And so I need you to focus. I need you to think. And so if you look at our function here, notice it's a bit different. We've got the x variable isolated. And in reality, the y variable is what's squared. Okay, so look back at the top of your page. Do you see on this one, it's the y that's isolated and the x that is the part that's squared? Okay, that's different. That's different. We are the other way around. What does that mean? Well, this is what it means. This thing is either going to open to the right or it's going to open to the left. Instead of it being a max or min, it's going to open right or open left. Okay. Now it's a horizontal. All right, keyboard, get out of here. Now it's a horizontal. All right, so that's quite a bit different. Well, hey, math is orderly. Math makes sense. So look right here. Let's go ahead and write the general form for this type. Okay. Look, A is right where you would want it to be. It is right there. Okay, right where you would expect it. It's the coefficient of the squared quantity. All right, great. What goes with the y? Now this, look, y is the vertical coordinate, and we want the, I'm sorry, I'm writing green, and I'm writing h. And k is the vertical coordinate, and we want k with the y. And in this case now, the h is going to be outside. There's our general form. There is our general form. Now, right? And so in this situation, what are the, so let's go through. All right, well, let's go through. So looking at this thing, all right, we know where A is, we know where H is, we know where K is, I hope. All right, so let's make things easier. Right here is H, right? The 3 is K, right? And the A is the 1. So remember now, I told you this thing either opens to the right or it opens to the left. So that's the first thing we want to figure out. What would you guess? The A value is positive, right? We have a positive A value. So which one do you think models better a positive A value? This one or that one? Which one would better model a positive A value? And you know what? I hope you said this. I hope you said, or I hope you thought, hey, when we were doing max or mins, a positive A went like this. It headed toward the positive values. Therefore, in these, I think a positive A is going to go like this, heading toward the positive values. Math is orderly. Math makes sense. That's why I like math. Not big on English, but math makes sense, and that's a great thing. So this thing opens right. Opens right. And what are the vertex coordinates? Well, look, this is still H, right? The X coordinate, and this is still K, the Y coordinate. So clearly, we've got 1, 3. What would the line of symmetry be? All right, now you got to be careful. Look, if this thing's going like this, the line of symmetry is now a horizontal line. And how do you represent horizontal lines? With a y equals, right? Not an x equal. X is vertical for x equal for a line. So what would be the line of symmetry? Y equals 3. Every point along the line has a y coordinate 3. Okay, let's graph our vertex at 1, 3. Okay, there's our vertex at 1, 3, line of symmetry, right? Y equals 3. Every point along that line has a y coordinate of 3. All right, now, Here's the tricky part on these. Because everything's flipped, the x's and the y's are swapped. It is easiest if instead of doing the x first, we do the y first. We choose values for y and find the corresponding x value. It is much easier. Okay, so watch, where are we at in y? I'm already at a 3, correct? I'm already at a 3 for the y. So my first y is going to be a 4. Going to be a 4. Okay, I know I got a lot of stuff up there. Let me erase what I've got up here at the equation so we can look at this. Okay, so look up here at the equation. So here's what we're doing. We're sticking a 4 in for the y, right? 4 minus 3 is a 1. 1 squared is 1. 1 times 1 is 1. 1 and 1 is 2. See what we did? Okay. We wanted to find the y. We want the y to allow us to find the x. All right, so let's plot that point. Now be careful. You got to plot it correctly. It's a 2, 4. 2 on the x and 4 on the y, right? So be careful there. Don't get all backwards. So we got a point right there. Line of symmetry, point right there. Beautiful. Okay, I'm at 4. My next point, I'm going to go 5, right? So again, look up at the function, put a 5 in for the y. 5 minus 3 is 2. 2 squared is 4. 4 times 1 is 4. 4 and 1 is 5. So we have the point 5, 5. Okay. All right, it's right there, right? 5 to the right and 5 up, point right there. Line of symmetry. I'm 2 up. I got to go 2 below. Right there. Okay, let's do one more point. Let's go one more. Let's go 6. So again, look up at the function. Put a 6 in for y. 6 minus 3 is 3. 3 squared is 9. 9 times 1 is 9. And 9 and 1 is 10. 6, 10. All right, be careful. The x is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm up 6. 1, 2, 3, 4, 5, 6 right there. So I'm 3 above the line of symmetry. I'm going to go 3 below the line of symmetry. Okay. What do I do? Dotted line or solid line? Dotted or solid? All right. Hopefully you say, hey, it's just greater than, it's not equal to. Got to be dotted because the points of the line are not included. Now, where are you going to shade for a greater than? Well, look, we're talking about an x-axis. On the x-axis, where do you get bigger? You get bigger to the right, don't you? So where are we going to shade? To the right. And this shading goes inside. To the left would be out here, right? And that's not where we are. Again, if you're not sure of that, use a test point. Do an easy point, something that's obvious. Let's go 1, 2, 3, 1, 2, 3. Let's use the point 3, 3. Okay, got to go way back up to the original. So look at the original function. Put in 3 for the x. Put in 3 for the y. 3 minus 3 is 0. 0 times 1 is 0. Is 3 greater than 1? Yes, that point worked. It is part of the solution. I got it right. I'm happy. You're happy. All right. Are you going to get a lot of these kind for number 6? No. Would I spend a lot of time getting this down? No. I really introduced 6 for your benefit for next year. All the rest, let's be up on and ready to roll. But look, math makes sense, and hopefully that makes sense. So let me do a quick recap. All right, remember, so you can have all kinds of different inequalities. Hey, I didn't show this, but what would happen if you had a does not equal to? Does not equal to. You know what you'd end up with? Something like this. You'd have a dotted line, but you know what? You'd shade in and you'd shade out. All of those are true. The only points not true are the points along the parabola shown by the dotted line, right? If you have a is not equal to. All right, remember, so you got to do solid line or dotted line, right? You've got to shade above or below. Figure out the max or min point first, line of symmetry, and then go ahead and shade. Could be in, could be out, above or below, and that's the lesson. All right, hope you have a great night.